Hi everyone. In this question, we've been told that y is the arsinh of the square root of x squared minus 1, where x is greater than 1, and we need to show that dy by dx can be given as this. Do you want to give this question a go yourself? You can pause the video, and then when you come back, we'll go through the solution. Okay, so welcome back. How did you get on? The first thing we'll do is we'll take the sine of both sides. And by taking the sine of both sides, the arsinh and the sine will cancel. So we're left with the sine of y equaling the square root of x squared minus 1. And now we can cancel out the square root by taking the square of both sides. So sine squared y will equal x squared minus 1, and we can use the hyperbolic identity with this sine squared y. If we look at the formula booklet, we can use this identity to write sine squared y in terms of cos squared y. So we'll move this term over to the right hand side and the 1 over to the left hand side. So sine squared y will be cos squared y minus 1, and then we can substitute this into here. And you can see that these negative 1s will cancel. And then we can take the square root of both sides. So cos y will equal x. And now we need to find dy by dx by differentiating both sides with respect to x. So we need to differentiate cos y implicitly. And this will give us sine y dy by dx. And then when we differentiate this x with respect to x, we just get 1. Now we can make the dy by dx the subject by moving this over to the right-hand side. So we get 1 over sine y. Now at this point, we know that sine y is given as the square root of x squared minus 1. So we can substitute this term in place of sine y. So dy by dx will be the 1 over the square root of x squared minus 1. And that's what we were asked to show here, okay? And then for part B, we need to find f prime of x. So we need to differentiate this with respect to x. And you can see a lot of the hard work's already been done because we've differentiated this term to get the term here. So when we differentiate all of this with respect to x, including a third, we'll get f prime of x is 1/3 multiplied by the 1 over the square root of x squared minus 1. And now we need to differentiate arctan of x. And this is a standard derivative given in the formula booklet. You can see that the arctan of x differentiates to make 1 over 1 plus x squared. So we can write this as minus 1 over 1 plus x squared. Now we're told to determine the exact values of x for which f prime of x equals 0. So we'll set this equal to 0. Now we can move this term over to the left-hand side and we can tidy this up. So we've got 1 over 1 plus x squared will equal 1 over 3 times the square root of x squared minus 1. Now we just need to move this denominator to the left-hand side and this one to the right-hand side. And to find the exact values of x, we need to cancel out this square root. So we need to square both sides. So we'll get 9 lots of x squared minus 1 will equal 1 plus x squared multiplied by itself. So we've got 9x squared minus 9 will equal 1 plus the 2x squared plus the x to the 4. And we'll move these terms over to the right-hand side to make it equal 0. So we've got x to the 4. The 2x squared minus the 9x squared will give us negative 7x squared. And the 1 plus the 9 will give us a 10. And this will equal 0. So we can factorize this. We need two numbers that multiply to make the 10, but add to make the negative 7. So we'll have x squared minus 2 multiplied by x squared minus 5. Can you see that when you multiply these two together, you get the x to the 4? And when you add these two terms together, we get the negative 7x squared. So x squared must equal positive 2, and x squared must equal positive 5. Now we're told that x must be greater than 1, so we don't need to consider the negatives. So therefore, x will equal root 2 and x will equal root 5. Okay?